Hello everyone, today we are going to start a new unit. We are going to learn kinematics, and let's start with the constant motion. But first let's define coordinate system, Cartesian coordinate system. This coordinate system is made of two axes, x-axis and y-axis. These two lines are perpendicular to each other, and the point where they cross is called the origin. For what we are using the coordinate system? We are using it for indicating the position of an object. For example, if an object is here, how we can determine its position? Then we need to look at the axis. This object is 2 units away from the x-axis on the x-axis, and it is on the y-axis, it is 1 unit. That's why I'm going to indicate its position as 2, 1. Let's look at this one, for example. Here, this point is on the y-axis, it is 2 units in the negative y direction and 1 unit in the positive x direction. We are first writing the x coordinate, and then we are writing the y coordinate. It is going to be 1, -2. Similarly, we can look at the other points. For example, what is the position of this point? For example, this point is in the y direction 1, 2 units. In the x direction it is 1, again 2 units. It's in the negative x direction, that's why this is going to be -2, +2. So these are the points, and we show their position relative to the origin. This is the origin. So what is motion? Motion is when the particle's position changes relative to the origin, relative to a reference point. When the position is changing with the time, it means it is in motion. For example, the object is initially here, sometimes later if it come here, this is its initial position and this is its final position. It means this object has moved from here to here. And position vector, on the other hand, assume you have an object at this point. The position vector is the vector drawn from the origin to the object. This is the position vector of this point. If object is, for example, somewhere here, then the position vector is going to be this one. So just you draw lines from the origin to the point. These are different position vectors. Let's look at the distance and displacement. Distance is the separation between 2 points. Okay, so this is the distance, and we are measuring it with meters. And distance is a scalar quantity. If you move in this direction, for example 7 meters, and then you move in this direction, for example 6 meters, and then if you move to this direction, for example 3 meters, then the total distance that you have moved will be here is the 7, here is the 6, will be 13, and here is the 3, it will be the 16 meters. So the total distance you have traveled will be 7 plus 6 plus 3 will be 16 meters. Displacement, on the other hand, is the distance between the initial and the final position of an object. So if you want to indicate the displacement, it is a vectoral quantity. We are just going to draw a line from the initial position of the object to the final position of the object. Let's place our coordinate system somewhere here. Okay, so where is the particle's initial position? Here is the particle's initial position vector, and here is the particle's final position vector, and let's say this is x1 and this is x2. These are vectors, position vectors. So the displacement is shown with delta x, and it's a vectoral quantity. Delta x is equal to x final minus x initial. So let's repeat. If, for example, you move to that direction and then this direction, and then, for example, you have moved somewhere here, then the displacement is going to be the arrow drawn from the initial point to the final point. This is going to be our displacement. Next, let's look at the speed, velocity, and acceleration. Speed is the distance traveled divided by time. So speed will be distance divided by time. And since distance is a scalar quantity, speed is also going to be the scalar quantity. On the other hand, velocity, let me show it with v, equals displacement, delta x over delta t. And acceleration is the change in velocity with the time. Acceleration is equal to delta v over delta t. So here the distance is changing with the time, we can find speed. If the displacement is changing with the time, we can find the velocity, and if the velocity is changing with the time, we can find the acceleration. I will do the examples of these equations. Let's learn the constant motion. Now assume an object is traveling, and we have this table, and we have this data from the motion of an object. Assume time is equal to 0, then it's 1 second, 2 seconds, 3 seconds, 4 seconds. And at the time is equal to 0, the distance, the position is 0, then it is 2 meters, 4 meters, 6 meters, 8 meters. Okay, so how can we find the velocity? Remember, the velocity was v is equal to delta x over delta t, and it is x final minus x initial divided by delta t is t final minus t initial. So for the time from 0 to 1, after 1 second, it has moved 2 meters. Its final position is 2 meters, and initial position is 0 meters. That's why x final minus x initial, it will be 2 minus 0, and it will be 2. Similarly here, it is 4 minus 2, it will be 2, and the time difference here, this is delta t is equal to 1 second, this delta t is 1 second, and these are all 1 seconds. So then this is also going to be the 2, 2, and 2. And on the other hand, acceleration is defined as delta v over delta t. And let's look at the velocity change. For example, from the first second to the second second, the time passed is 1 second, and the velocity here is 2, here is again 2. So acceleration is v final minus v initial divided by delta t. Since the initial and final velocities are equal to each other, this will show us that the acceleration is 0, 0, 0, 0. Let's draw the graphs. Let's draw first the position time graph. Our time is 1 second, 2 seconds, 3, 4 seconds. They are here. And after 1 second, its position is 2 meters. Assume this is 2, 4, 6, 8. So this is the position after 1 second. After 2 seconds, the position is 4 meters. Here is the second position. At third second, this is the position. Fourth second, this is the position. So the xt graph is going to be this. Okay, so let's look at the vt graph. Now, as you see, let's say this is v, meter per second, and this is time in seconds. So as you see, the velocity is always 2. The time is 1, 2, 3, 4. Okay, at the first second, the velocity is 2. Assume this is 2, 4, 6, 8. At the second, at the first second, the distance was 0, and it is 2 meters. The distance is 2 meters. At the first second, the velocity is 2 meters per second. At the second second, it is again 2 meters per second. Again 2 meters per second. Again it is 2 meters per second. So as you see, the velocity does not change with the time. So it is always equal to 2 meters per second. Finally, let's look at the acceleration. Acceleration is equal to delta v over delta t. So v final minus v initial divided by delta t. And acceleration is always 0. It is indicated here. I explained it. So the time is again 1, 2, 3, 4. But the acceleration is always going to be equal to 0 because the velocity is not changing. Okay, let's look at an example. This is xt graph. And now assume this is 50 meters. And here is 100 meters. An object is at the beginning, and this graph shows the motion of an object. What does it mean? So this is the origin, here is the origin. And initially, object is somewhere here. At time is equal to 0. The object is 50 meters. This is in meters. It is 50 meters on the left of the origin. So let's draw it here. Assume this is the 0 point, and the object is somewhere here. Assume this is your object, and it is at the negative 50 meters. Then this object is moving. The time is passing. The object is moving toward the origin. It will move toward the origin, and after for example 10 seconds, 20 seconds, 30 seconds, after 10 seconds it will reach to the origin. Then it is now moving, and as you see it's moving like this. So it is moving to the origin, and then it moves away from the origin to the 100 meters. If this is the 15th meter, this will be the 100th meter. So this one shows the direction, I mean the distance. The object starts at the negative 50 meters, and then it comes to the origin, and then it moves to the 100th meter. So let's look at the distance the object has traveled. The distance we indicated with x, it moves 50 meters up to the origin, and then it moves 50 meters passing the origin, and then one more 50 meters. Totally 50, 50, 50, it moves 150 meters. And let's look at the displacement. Displacement is delta x equals x final minus x initial. So now be careful please, what is object's initial position? The initial position vector is from the origin to the object. It is a vector and it is negative 50. But the final position vector is drawn from the origin to the object. It is at the 100th point. So this is 100 and this is negative 50. So x final, the final position is 100. This negative of the formula, then x initial is negative 50. So it will make 150 meters is the displacement. And as you see, the distance and displacement are equal to each other. Why? Because the object is moving along a straight line. Then let's calculate the speed. Let me denote the speed with s. The distance traveled divided by time. So the distance traveled is 150 meters. Divide by total time passed. At the time was 0 here, then 10 seconds, 10 seconds, 10 seconds. Totally it makes 30 seconds. So speed will be 5 meters per second. And then let's look at the velocity. And the velocity, remember, it was delta x divided by delta t. So the displacement was 150 divided by the time passed, again 30 seconds, and it is going to be equal to 5 meters per second. Here the speed and the velocity are equal to each other, but please be careful that one of them is scalar and the other one is vector quantity. Then we can draw velocity time graph. For example, here this is t and this is v, and the velocity is not changing with the time. It is 5 meters per second. It is up to 13th second. It is not changing. And I want to move back to my constant motion graphs to explain a little bit more in detail the constant motion. During the constant motion, remember, here is the xt graph and this is the angle with the time axis. So the tangent of this, the tangent of this angle tangent theta is equal to velocity. If you want to find the velocity, for example, let's look at the tangent of this angle. For example, this one, it is 4 at this point. Here is 4 on the on the x-axis, and here is 2. So, for example, it is 4 over 2. Or, for example, let's look at here. Here's 8 over 4. Always 4 over 2 or 8 over 2, it's always equal to 2. It's always equal to 2 meters per second as indicated here. So that the tangent of the angle, this angle, gives us the velocity of the object. And the area under the VT graph, here is our VT graph, and this area gives us the displacement. Here is the area. And this area will be equal to, this is the velocity and this is the time axis. The area is equal to velocity times t. And here is the velocity is 2 meters per second and the time is 4 meters. So the total area 2 times 4 will be equal to 2 times 4 is going to be equal to 8 meters, and this is equal to the displacement of the object. The area under VT graph, here is the V and here is the T. The area under the VT graph gives us the displacement of the object. Okay, let's now move to another example. Here is the second example, and this is time axis again, and this is the x-axis. An object is moving, this is the origin, moves from the origin up to here. Now assume this is 10 meters. This is in meters, and here will be negative 5 meters. The object initially moves to 10 meters. It moves away from the origin 10 meters. And now assume this is 2 seconds, 4, 6, 8, and this will correspond to 9. Here is 10. The object moves away from the origin, 10 meters it moves away from the origin. Then it does not change, the position does not change for between 2 seconds and 6 seconds. About 4 seconds the object stops, it does not move, and then it moves back to the origin again, and then it moves back to the negative 5 meter. So let's look at the displacement and distance traveled here. The displacement, let's first look at the displacement, is equal to the distance between the final, x final, minus x initial. So this is the initial position, it is 0, and finally it is negative 5. The final position is negative 5, so delta x will be equal to negative 5 minus initial position is 0, so it will be negative 5 meters. And then velocity here will be equal to negative 5 divided by the total time is 9 meters per second. Let's look at the total distance traveled. Initially it moves 10 meters in the x-axis, then plus here it does not move, it's 0, plus it moves 10 meters back to the origin, and then it moves 5 meters to the left of the origin. As you see, I am not looking at the sign here in the case of the distance traveled. We are not interested in the sign, just the distance traveled is important for us here. It will make 25 meters. Totally, the object moves, for example, it moves from the origin 10 meters to the right, and 10 meters to the left, and 5 meters to the left. Totally, it moves 25 meters. Then speed will be equal to distance traveled is 25 meters divided by total time is 9 seconds, so it will be 25 divided by 9 meters per second. As you see, the velocity and the speed are different from each other here, and from here we can draw the velocity time graph of this object. Now let's look at the tangent of this line to find the velocity here. Remember, the tangent is equal to this height divided by this length, so it is 10 divided by 2, it will be 5. So here velocity is 5 meters per second. This is v and this is t. And then here, as you see, for 4 seconds up to 6 seconds, the distance is not changing. Since the distance is not changing, the velocity will be 0. Then as you see, let's look at this angle to find the velocity here. This angle is looking to the negative side, and this is going to be the negative velocity. It's moving in the negative direction. As I indicated here, it moves 10 meters to our right, and then it moves 10 meters. Initially it moves 10 meters to the right, and it stops here for 4 seconds, and then it moves back. While it's moving back, this one shows the moving back, so it is a negative velocity. Again, height divided by this length, this is 10 divided by 2, it will be negative 5 meters per second. This is negative 5. Then finally, the object is again moving toward the negative direction, so these two angles are equal to each other, and that their tangents are equal to each other. It means the velocity is the same. So this is going to be the velocity up to the 9th second. This is 2, 4, 6, 8, and this is the 9th second. So remember, I told you that the area under the VT graph gives us the displacement. So here is the area under the graph. This area is 10, and here we don't have any area, it is 0. And now let's look at this area. It is negative 5 times from 6 to 9, it is 3 seconds. So this area makes 3 times negative 5, negative 15 meters, and this was 10. So the total area under the graph is going to be equal to, the area is equal to 10 minus 15 is equal to negative 5 meters squared. So the displacement, the area here equals to the displacement, so it is equal to displacement of the object. As I wrote it here, again it is again 5 meters per second. Okay, that's it. Thank you for listening. See you next time.